Okay, this is your section 7.2 material, finding the truth. So we're going to be talking about truth tables. So in 7.1, I told you that we weren't worried about identifying the truth value of any of the statements, that we would do that later. And now it's when we get to do all that. So our learning objectives is that we're going to build truth tables for negations, conjunctions, and disjunctions. So remember, a conjunction uses a connective word and. The disjunction uses the connective word or. We're going to build truth tables for the conditional, biconditional statements. Those are the if then, and then the if and only if. And then we're going to build tables for compound statements, and then use the hierarchy of connectives and compare it to the order of operations. So basically, once we cover this section, we will be able to create or find the truth value for any type of situation. Okay, so first let's talk about the negation. So the truth value for a negation, the negation is simply the opposite truth value of the given statement. So this lesson's all about deciding when a compound is true or when it's not based on the topic of that statement. Okay, so guys, here's what we're going to do. So if we have a statement P, it can either be it's got to be one of two things. It either has to be true or false. Okay, but it can't be both. That's one of the things that we said at the very beginning. So your statement of P could either be true or false. Well, if I start off with a statement that's true, and then I have not P, then that means that it's not true, then this would be false. And if my statement is false, not P, not false would make it true. So it's just the opposite truth value. Okay, so no big deal there about the negation. Okay, now what you are going to have to remember on your own, because I'm not going to set this up for you, I will give you the table. I have to give you the table so that you'll know what I'm looking for. Okay, but what I am not going to give you are these 8 truth values, and you're not going to be given the explanations to the side here. So you have 4 basic types of scenarios. Now, this is when we only have 2 statements that we're looking at, P and Q. We could have 3, P, Q, and R. We could have 4, P, Q, R, S. I can ask you all kinds of things to find the truth value for, but you are going to have to remember this. So you have the scenario when P is true, then Q can either be true or false. And then we're going to repeat that same scenario, but this time, whenever P is false, well, still Q could either be true or false. So these are your 4 setups that you will always start your table with. Okay, so let's look at the conjunction and. So it says the truth values for a conjunction. The conjunction P and Q is only true when P and Q are both true. So I'm going to, for purposes of this example, I'm going to be a jerky boss. So P is that I tell you that you have to be on time, and Q, you also have to wash my car. So if I tell you, I'll give you a raise if you will come to work on time and wash my car. So the only time that you get a raise is when you do both of those things. Okay. So if you want a raise, well, were you on time? Yes, that's true. Did you wash my car? Yes. Okay. Then I'm going to give you a raise. All right. Now, again, here we go. Were you at work on time? Yes. And then, did you wash my car? No, you did not wash my car. Then you are not going to get a raise because of the word and. Remember the and is the intersection. It has to be what is from both, what's common from both sets. Okay. But here we're only talking about one idea, but both have to happen. So now, were you at work on time? No, you were not. But did you wash my car? Yes, you did. Are you going to get a raise? No, you were not, because you did not come to work on time. And then here, did you come to work on time? Nope. Did you wash my car? Nope. And you're probably at this point, and this is the person who's like, I'm out of here. I'm not going to do all this stuff for this guy. Okay, so again, you can see how, back to what this is saying, that the conjunction P and Q is only true when both P and Q are true. Okay, so notice that these these 8 truth values are the same 8 that you have to remember to start off with. Okay, so once you do that, then you can answer the whatever it is I'm asking for. In this case, I was asking for the conjunction. Okay, same scenario. All right, P, you have to be on time. Q, you have to wash my car in order to get a raise. All right, so I'm gonna just cheat. Remember, these are the 8 truth values you need to fill in automatically. Okay, now this time, this is a, whoops, this should say disjunction. How did I miss that? Okay, so the disjunction P or Q is true. It's always true unless both P and Q are false. All right, so again, I will give you a raise under the condition that you come to work on time or that you wash my car. So in order for you to get a raise, you either have to be on time, or you have to wash my car, or you could do both. Okay, so were you at work on time? Yes, that's why it's true. Did you wash my car? Yes, you did. Then I'm going to give you a raise. Okay, now for the next one, were you at work on time? Yes, that's true. Did you wash my car? No, you did not. Are you still going to get a raise? Yes, because you have the connective word or. So again, you get the raise if you are on time or if you wash my car. So you only really have to do one of them. You could do both and hope that you'll get a bigger raise. Okay. So this one, you were not at work on time, but you did wash my car. So I'm still going to give you a raise. And here, you didn't come to work on time. You didn't wash my car. So I'm not going to give you a raise. So again, we look at this. The disjunction is true unless both P and Q are false. Okay. Same thing as, would you like cake or ice cream? Cake, yes. Ice cream, yes. Okay, you got them both. Would you like cake? Yes. Ice cream? Nope, but you're still going to get the cake. Okay. Would you like cake? Nope. Would you like ice cream? Yes. No problem. I'll give you ice cream. And here, would you like cake? No, thank you. Would you like ice cream? No, thank you. Well, then there's nothing for me to give you. Okay. So the or for either P or Q or both have to be true. The only time that it's false is if they're both false. Okay, now this is the fun one. So the conditional statement, if then, our if then statements. This one's kind of, at first it's kind of tricky to understand, but once you look at the Venn diagram, it makes a whole lot of sense. Okay, so a conditional statement, which is sometimes called an implication, consists of 2 simple statements using the connective if then. Okay, so for example, if I bought a ticket, then I can go to the concert. That is a conditional statement. The first component, so I bought the ticket, that is called the antecedent. Okay. The second component is I can go to the concert. That is the consequent. Okay. Now remember, we also said that these were considered, we also call these conditionals. I mean, this is why it's a conditional. All right. You can only go to the concert if you bought the ticket. If you didn't buy the ticket, then you can't go to the concert. Okay. So now we're going to use P and Q here to talk about the 4 cases that can happen. So again, here is our truth table. I'm going to assign those 8 values that we always start with. And then we're going to talk about this because some of these don't make sense. It's kind of weird, but once I show you the Venn diagram, it'll make a little bit more sense. Okay. Hang on just a second. Let me fix this. Okay. I can skip that down. All right. So for the 4 cases, so the first one is that the Cubs win tomorrow and they make the playoffs. Okay. Well, that's a true statement. Look at the intersection. Here is the Cubs win, and here is the playoffs. So notice the intersection. So that's true. If they do win tomorrow, they made the playoffs. That is a true statement. Okay. Now, this is the weird one. If the Cubs win tomorrow, but they don't make the playoffs. Well, if they don't make the playoffs, then that means you would have to shade everything outside of the playoffs circle, which means you would not have this part. But it doesn't make sense because it said that if the Cubs win tomorrow, they will make the playoffs. So how could they win tomorrow and on one hand make the playoffs and on the other hand not make the playoffs? So this one is false. That one's not true because look at the intersection. Look where they both exist. The Cubs win and they made the playoffs. So you can't dispute that. They are going to the playoffs if they win. Okay. Now, the last 2 cases, 3 and 4, this is where it gets a little weird. The Cubs lose tomorrow and still make the playoffs. This is actually true. And the Cubs lose tomorrow and don't make the playoffs. That is actually true. Now, watch. If the Cubs lose tomorrow, now this is not, I couldn't get a better picture of this. If the Cubs lose tomorrow, then nothing, this part should not be shaded. Okay, if they lose tomorrow, that's the complement of this circle, which means everything outside. Okay, now if it's everything outside this circle of the Cubs winning, okay, do you see how they're still in the playoffs? If they don't lose, that's everything outside this circle, but they're still in the playoffs circle. So that's true. Look at where it put them. That is a true statement. Now, if they don't make the playoffs, if they don't win tomorrow, so outside of this circle, then they're not in the playoffs. Okay, well, remember, it's everything outside of this circle. And because I couldn't shade, I had a hard time trying to figure out how to shade all of this. That also includes this part, all of this, everything that's outside the circle, which means it's still true. So if they lose tomorrow, then they don't make the playoffs. And if I'm out here, I'm also outside of the playoff circle. Okay. And that's why that is also a true statement. So it's kind of weird, but it makes a whole lot of sense when you see the Venn diagram, when you see the picture of it. Okay. This is the one that is probably, it might give you a little bit of some trouble. So just make sure that you memorize this, okay? So the only time that it's false is if P is true and Q is false. So the antecedent is true. Why this is doing that? What happened here? And the consequence is false. There. Now that's correct. Okay. All right. Now the biconditional, the explanation kind of takes you all the way around the block. And then I'm going to show you something that is necessary, but I'm just going to do it because it's in the book. And if you look at the book for help, then it's there. All right. So a biconditional statement, the conditional P with the double-sided arrow to Q is true when P and Q have the same truth value and false when they have the opposite truth value. Okay. So for example, the statement, I will stay in and study Friday if and only if I don't have any money, is the same thing as if I don't have any money, then I'll stay in and study on Friday. If I stay in and study Friday, then I don't have any money. Okay. All right. So in symbols, what this means is notice that this is the conjunction of two conditional statements, P then Q and Q then P. All right. Since the biconditional statement is a conjunction, for it to be true, both statements, P then Q and Q then P, must be true. All right. So this is what you would start with. All right. Now let me fill this in. This part over here is what we just did for our conditional. Okay. Okay. So now let's look at this. So P then Q. Well, that's just what we did. So that means this is going to be true, false, true, true. Now I need to answer if Q then P. So if true then true, let me hide this for just a second. Okay. So if true then true, true then true, then that's going to be a true statement. If false then true, false then true, that's a true statement. If true then false, this is the only one that gives you the false statement. And then if false then false, that's true. So true to false is the only one that will get you a false statement. All the rest are true for the conditional. Okay. Now, when we look at P, if and only if Q, well, they both, the statements have to be true. So P then Q and Q then P, both of them are true. True and true. That's a true statement. That's the conjunction. So that's the one where you come to work on time and you wash my car, you get a raise. You don't come to work on time, but you wash my car, sorry, you don't get a raise. You had to do both. You come to work on time, you did not wash my car, but you get a raise. I'm sorry, false. And then this one is true. Okay, so they both have to be true. Now, they could have, oh, wait a minute. Oh, no, that's true. That's right. So since both statements have, well, this is the part. Sorry, guys. Let me put this back before I forget. Okay. So that was the kind of long explanation that the book does. And I don't like it because it's just really, really long. But we didn't even have to do any of this. Okay. And so here's what I'm going to do. I'm going to hide this. Now look, does true go to true? That's true. Does true go to false? No. So these truth values are not the same. Is false the same thing as true? Nope. So that's false. Is false the same thing as false? Yep, that's true. So again, as long as P and Q are the same truth value, then the biconditionals are going to be true. If they're different, then they're going to be false. Okay. All right. So let me put this back. Put that in red, and then this part has to go in black. All right. Okay. So now let's look at building. Whoops. Let's look at these tables. Here we go. Oh, no. We did talk about all of that. Okay. So we're going to build a truth table for the statement. Well, we've already done this one. So if true, then true, that's true. If true, then false, that's the one that's false. Then these last two, if false, then true, that's true. And this one's true. Okay. All right. Now we're going to do the same thing here. We're going to fill in P and Q. That's what you always have to know. All right. Now, just to help you out, I'm going to hide this because I don't want you to get confused. So we're finding this statement, not P or Q. So not P. Well, if P is true, not P means that's false. If P is true, not P, this would be false. This is true, and that's true. Okay. Now I'm going to go ahead and show the Q column again, but this time I'm going to hide the P column because we are only looking at not P and the Q. Now this is an or. So remember, you get a raise if you come to work on time or you wash my car. So only one or both have to be true. So this one's true, even though that one's false. So that's a true statement. Both of these are false. So that's a false statement. Both of those are true. That's the suck up. He wants the raise. And then one of these are true. That's true. Okay. Put that one back. All right. Now let's look at 7. So we're going to build a truth table for the given scenario. I'll do my math, or if I think of a good topic, then I'll start my English essay. So I see 2 connectives. I'll do my math assignment, or if I think of a good topic, then I'll start my essay. And this is where, back up at the very beginning, when we talked about using the hierarchy of connectives and comparing it to order of operations, that's what this is talking about. So notice that here's the or. So it's this or this. I'll do my math assignment, or then I have this if then statement, which is a conditional. Okay. So what we have to do first is I need to assign P, Q, and R. This isn't showing up. All right, that's okay. Here we go. So P equals, that's going to be the first statement that we have, which is I'll do my math assignment. Now, when we label P, Q, and R, we're not worried about the connectives. We just have to label them. Okay, the next one is going to be Q. So Q is, here's the or. So now if Q, so I think, whoops. Okay. So here is Q. I think of a good topic. Then here's the R. I'll start my English essay. So we labeled P. I'll do my math assignment. And then our if then, if this part, if I think of a good topic, that's Q. Then I'll start my English essay, that's the R. All right. Okay, now here we go. So now remember, you had to fill out the first four. Now, because we have a third variable, this is going to look a little different. So the more variables you have, the longer this table gets. Okay, so I've got these 8 truth values. All of this is going to happen when R is true. Okay, now the same thing has to happen again, except this time R will be false. Now, if I had a fourth variable to put in here, then I would have to use another letter. So if I had S, then I would have all of this when S is true. And then I would copy this again and have all of this one more time when S is false. So it just gets longer. Okay. All right. Now we want Q, then R. If Q, then R. So we come back up here. Here's our conditional. Remember, the only time that our conditional statement is false is when true. If true, then false. That statement is false. So if it's T to F, it's false. Everything else is going to be true. Okay. True to true, that's true. False to true, that's true. True to true, that's true. False to true, that's true. And here it is, true to false, that's false. False to false, that's true. Here's another one, true to false, that's false. And then false to false, that's true. Okay, so now we want, I'm going to hide this. Now we want P or this conditional column. P or if Q then R. Okay, so it's the or. So that means, would you like cake or ice cream? So you can have either or both. Okay, so as long as you get one, at least one true, then it's true. So this is true, 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 true. This one, since both of them are false, that's false. This one's true. All right. And that's how you fill out your truth table. All right. One more. All right. So build a truth table for the given scenario. Life moves pretty fast. If you don't stop and look around once in a while, you could miss it. And this is a line from Ferris Bueller's Day Off. Okay. Now, we are not going to worry about this sentence. Okay. This is the part that we want to worry about. If you don't stop and look around once in a while, you could miss it. If that's the beginning of a conditional. So if blah, 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 then here's the implied then, you could miss it. All right. So here we go. So P, Q, and R. I'll change the color in a minute. So P is going to be this first part. You don't stop and look. You don't, I'm sorry, you don't stop. Then we have the connective and, which means that's going to be our Q. So that's going to be look around once in a while. then you could miss it. So that's your R. Okay. So if P and Q, if you don't stop and look around once in a while, then you could miss it. So if, and again, order of operations, we have to do this one first, not P and Q. All right, so there's my first 8 truth values. That is when R is true. And then I have a repeat this time when R is false. Okay. Now again, just to help out, it's probably going to be good for you guys if you have, sometimes when you see all these letters, you kind of get confused and accidentally look at the wrong column. I would have something, just like a pencil or something to cover up the letters you don't need. Okay. So that you can only look at the right one. So we're going to look at the P column because we need not P. Okay. So if you don't stop, don't. So there's the not P. You're not stopping. You're not stopping. You're doing the opposite, 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 opposite. Okay. Now we want not P and Q. So let me cover this one up and R. Whoops. Let's see, and R. I'll cover these two up. Okay, not P and Q. So they both have to be true. Otherwise, it's false. So this one's false, false. They're both true. That's true. False, false, false. These are both true. And then this one's false. Okay. Now I need not P and Q. And I also need my R column. So I'm going to hide or cover up whatever you want. You don't have to do this. If you can go through it just, without it, and good for you. Okay, now here's our conditional. P then Q. So remember, the only time that we get a false statement if it's true going to false. All right, so we want this column. If this column, then this column. False. So remember, true to false is the one that is false. Everything else is true. So this one is true, false to true. That one's true, true to true. This is true. Whoops. True. False to true. That one's true. False to false. We're okay. False to false. We're okay. True to false. That's the one. That's false. And then false to false is true. And that is how you fill in your truth tables. Okay. All right. And your problems are going to look exactly like this on the test. So let's see. The only thing I needed to do was put this in red. All right, guys. That's it. Let me know if you have any questions.